and give you some tips in order to implement it with your team. So Steve, come on up.
Thank you very much. Okay, hi, and welcome to this talk. So I should probably get the clicker first. That would probably help. So I want to talk a little bit about Docker and continuous integration and Docker and testing. So the thing about Docker is most people talk about Docker as a deployment technology. It's something you get your sysadmins to put into your production servers, and that's suddenly going to make your problems go away. That's not the case. However, it actually has other uses in you. Even if you're not adopting Docker in a production environment or even your staging environment, it can actually be useful to you as developers right now. So, the question would be like, why would it even do this? Isn't this a deployment technology? No, it's used as a deployment technology, but even if you're not considering it for production, there's problems it can solve for you right now. In particular, problems around integration testing, advanced integration testing, not unit testing. This is when you really want to be 100% sure that your systems are going to work. So this is sort of getting a bit abstract, and I want to try and nail it down to something concrete. So I'm going to show a real problem that we had on our team, or specifically I had this problem on this team because I was arguing with the team about whether my solution would work or not. So what we had, I was to work on something that was at the time called the internal systems team. Now I think it's called purchasing. But we wrote the ordering systems that you've integrated with, you've interacted with if you've ever bought Jira or Confluence or any of these tools. Now we use Postgres as our source of truth. The reason we use Postgres as a source of truth is because it is transactional. It is ACID. We are dealing with money. You would not be happy if you gave us money and you got nothing for it. We wouldn't be very happy if we gave you an expensive license and then we'd fail to actually register that in our accounting systems. We have to be transactional. But the problem is there's a lot of historical information in our database. It goes back to the early days of Atlassian. A lot of this is static. A lot of it doesn't change at any time. So we're putting a lot of load on our database for a good reason. It was read-only data. It didn't need to be transactional. It just needed to be available. So wouldn't we ideally want to offload it onto an external, more scalable system, something like Elasticsearch? Elasticsearch is very scalable, horizontally scalable. You just throw more servers at it if you have a problem, and it automatically integrates them in. The problem is these don't integrate very well. There are theoretically ways of doing it using polling systems, but in practice, they don't work very well. And in particular, if we're going to be reading off this external system, we want it to be near real time. If you've just paid us for a Jira license, you want that Jira license right now. You don't want it in half an hour's time when it gets around to polling the database. You don't want the system polling away, using up your database resources for no good reason. You want it to be a little bit more smart. So how do you get your data from your Postgres system into your Elasticsearch system in a scalable way? I had a theory about this, and I wanted to prove it. So what I built was something in between. It's called transfer because I haven't got much of an imagination. But what it does is it uses a proprietary extension to Postgres. Very important. Only Postgres supports this. So what it does, it uses something called asynchronous notifications, whereby a system can connect to Postgres and receive information from it in real time in a discrete way. We can use that in conjunction with the normal SQL standards of triggers and stored procedures to allow us to say if a row in a table is added, removed, deleted, modified, whatever, we will get a notification about that. In the middle sits my system called transfer, which I wrote in Closure, as it happens. And that will receive these notifications, pull the information out of Postgres, manipulate it in, denormalize it, all the things you want to do in a NoSQL world to make it highly efficient, shove it into Elasticsearch. So I had this proof of concept. I built it, I thought it worked. Could I prove it worked? And more importantly, could I prove that it was fast enough to solve our problem? How do you test something like this? And more importantly, how do you repeatably test something like this? And how do you do so inside a continuous integration environment? So we're going to do this properly. We want to run this against various versions of Postgres. We want to run it against various versions of Elasticsearch. You can't unit test your way out of this problem. This only works with Postgres And if you're not testing against a real Postgres instance, it's not really going to work. So you need this real Elasticsearch and real Postgres, and you want it to run on your desktop, your development environment, and in your continuous integration, continuous deployment environments. So how do you do that? Well, the way we traditionally did this in Atlassian, which was less than ideal, and we've got much smarter about this, was we generally just shoved dependencies everywhere. Every single one of our agents would have versions of MySQL on it, PostgreSQL, Oracle in some cases, DB2, all these things that most people don't use, but we have to support them in some way. It's hard though, particularly if you're using something like Amazon Elastic Bamboo, where you basically do scalability and you produce AMIs, Elastic Bamboo images that must contain all these dependencies. Every time you want to add a new version of Postgres to test this, you've got to create a new AMI, shove it up, the whole works. What about using virtual machines? Not too bad. This is how I actually did it originally, particularly using Vagrant, which can build virtual machines on the fly. The problem is they're very slow. They take several minutes to build, several minutes to boot up in some cases. And you've got to install this everywhere again. You've got to push it all out into your Elastic systems, into your build system. Everyone has to run this locally. Doesn't really work. About this time, my colleague Nicola Paolucci was getting really into Docker, and he started one of very much the early adopters and early evangelists for the Docker way of doing things. And I sat next to him. It's always interesting to sit next to Nicola if you get a chance. And he was espousing the benefits here, and I was wondering if you could actually use this to solve the problem. So would Docker solve this issue for us? Well, it turns out it has a couple of really nice features to help with testing. One of which is most people have done the work for you. There is a Docker hub where people share various images that are pre-made, and some of them are official images from the Docker Inc. itself. So you can reuse these. You don't need to build your own systems. There are actually a lot of stuff out there ready to go. Elasticsearch and Postgres in particular has a lot of official images. Startup speed is very fast. Because a Docker container only contains the application it needs, and it intends to run one application, and all it is really carving out a little bit of virtual memory and space inside an existing Linux kernel, it starts up almost instantly. Almost all the startup time is the time it takes for the actual application to start, not the actual container. So very, very fast. That's great, because that makes it idempotent. Not in and of itself. Docker containers have state, but if they're fast to create and fast to destroy, screw it. Destroy them. With the next run, fire them up again. Doesn't matter. It takes a few seconds. This means you can basically get repeatable tests. All that stuff you do with setup and teardowns in unit tests, you have to do in your production systems, particularly if you've got long-running Postgres servers, doesn't matter. You want to reset it, you just destroy the container. The other one is that your development and test will match. If you're running the same infrastructure, the same images in your CI environment as on your desktop, then it's going to be repeatable. It's going to be a lot easier to find out what problems went on inside your CI. Often you have this situation where you have a bunch of agents run, and some problem occurs, and then the agent is shut down, and you can't really see what happened. Doesn't matter. You can actually repeat everything using the same Docker containers. The other one is they are composable. This is a really powerful part of the Docker way of doing things, is you build small, self-contained containers to do one thing, run Postgres or run Elasticsearch, and then you bind them together at runtime. You glue them together into little mini networks, and you can create and destroy these networks, try out different things, and you just build up from very small building blocks. So this really worked out quite well for us. How this works in practice is what you do is you, as a developer, use Docker, the Docker command line. It creates a Postgres container. It creates an Elasticsearch container. And then it fires up our little test container that contains the application we want to prove. It runs through all its tests using Elasticsearch and Bamboo. So Elasticsearch and Postgres. And then it saves the test results and shuts down. And you can just do that again and again. And so you can try this. Well, that worked with Postgres 9.1. Let's try it with 9.2. Just point to a different Postgres image, run the test again, and that worked. You can have lots and lots of different branches testing against lots and lots of different versions of Postgres or Elasticsearch. So this is a really, really powerful way to test. So far, so good. It's less than 10 minutes, we're done. But there is obviously a little bit more to that, and obviously this is an Atlassian conference, so let's expand a bit more. This is an idealized image or an idealized layout of a bamboo pipeline. I don't claim it to be super accurate. It's just kind of jotted down from what was in my head that I was doing a talk about how to explain bamboo to people, to third-party experts. But I'm going to drill down into a couple of points along here where bamboo can really help with what I've just explained to you. See, as of March this year, Bamboo gained first-class Docker support in two important areas, in the area of something called a Docker task, and more importantly, in the form of Docker-enabled AWS Elastic Bamboo images. And these will make your life a lot easier if you want to try this out. So I'll take you to the Docker task first. So the Docker task is something, again, if you ever use Bamboo, you build up pipelines out of stages and then jobs and then tasks inside the jobs that operate sequentially. So this Docker task, what it can do is three things. One, it can build images, it can run images, and it can push images up to remote repositories. These are pretty much the three main operations you're going to want to use. The first one you can do is build. That's pretty straightforward. What we generally would do is have our Docker files checked into Git. Docker file, by the way, if you're not familiar with it, is the basic source file of a Docker image. It literally says, this is how you build an image from scratch in a repeatable way. So you basically, it's basically like a build file. So you run build against that, and it pops out an image out of the other end. You can actually specify the images ideally inside your Git repository, or if you want to experiment a bit, you can actually literally just type them out into the task right here and try them out. But generally, you're going to want to treat them as source code because they are. You can also run these images as well once you've built them, or you can run any third-party images that are available to you. That's pretty handy by itself, but also you can run them in detached mode. So these tasks operate sequentially. So ideally, if you're going to run a task, a Docker container you want to interact with, you're going to want to run it in the background. So it'll run it in the background, it'll monitor that, and at the end of your run, it'll shut it down and clean up after itself, which is very handy. But there's also a very, very other important part of this. Those images that are running in the background, the containers, you can link them in. So what you can do is you can run your Postgres image in the background, you can run your Elasticsearch image in the background, and then you run your testing image in the foreground, and you say, by the way, Bamboo, please link those two previous images, make them available to my testing image. And it wires it all up for you. Now, if you ever worked with Docker on the command line, it is a real pain to get that working. Really quite elaborate set of commands, very easy to get wrong. But Bamboo will do this for you. It'll do all your wiring up for you. The other thing, this is the other major thing, and this is really where the win comes in. From Bamboo 5.8, March this year, our AWS Cloud images, aka Elastic Bamboo, have first-class support for Docker. They come with Docker out of the box. Now, I don't know if you've used or aware of the Elastic Bamboo. It's a very powerful idea. You run up your Bamboo server, you put in some AWS credentials, and it will start creating images for you on the fly. The more jobs you have, the more agents it will create, and you've got this what's called Elastic. It will scale out as your builds grow, and it will shut them down as things become quiet. Obviously, this is all configurable, how many you do, what your upper limits are, and so on. We've got 3 images that have first-class Docker support inside them. 2 of them are stock Amazon images that have been modified to run Bamboo and also have Docker. And there's an Ubuntu stock image, very much the same thing, depending on how you want to do it. However, if these aren't quite satisfactory for you, you can build your own. There are instructions on our developer site about how to build your own AMIs. It's a bit fiddly to do by hand. I wrote a blog post recently. It's on developer.atlassian.com, our developer blog site. And that explains how to do it using something called Packer. Packer allows you to take an existing AMI, probably one of ours, and add and modify and update things as you want, and then push them up into the AWS cloud and use them. So that's quite a useful way of doing things. So check that out if you are interested in doing this. This is great because now Docker, you don't have to get anyone else involved in getting Docker running for your continuous integration environment. If you've got the latest version of Bamboo and you're using Elastic's web services, the Elastic Bamboo, you've got Docker support out of the box from the word go. The way to use it is actually quite simple as well. Like most things in Bamboo, you want to use requirements. Agents have capabilities. They know that they have certain versions of software, certain JDKs, certain versions of databases, and they also know that they have Docker support. So all you do is when you're setting up your tasks, you say, please make sure that this job runs on a Docker capable image. And if you're using the Bamboo tasks, that will do it automatically for you. If you want to run all this by hand, you don't have to use the tasks. You can just use the command line if you want to use that. But if you're doing it by hand, it's probably easier to use the tasks. But as you can see here, we've got a Docker capability requirement, and we have 5 Elastic images which are capable of running that. So you just say, give me a Docker image, and I'll do the rest. I'll supply the images that you need to run. However, this is actually making things a little bit more complicated than we need to. So obviously, if you're going to run on your desktop environment, you're going to want to run a bunch of commands that run up your this configuration for testing. Of course, you want to run that in your CI environment. Now, you could script this up for repeatability, but there is actually a better way of doing it. So a while ago, Docker Inc. bought a company called Figtree. But they produced a tool called Fig. The reason it was called Fig was because the author was fascinated by the life cycle of the fig and the symbiosis with the fig wasp. I won't go into it because we might be serving figs at some point, and I don't want to put you off them. But suffice to say, a wasp must die for a fig to live. Put it like that. Go look it up later when you're not eating figs. But what you do is instead of doing all this manually, you put Docker Compose. I've decided to use Fig instead because I love the image. But you run Docker Compose, and Docker Compose will do all your wiring up for you because you just supply a configuration file called compose.yml or dockercompose.yml. It's a YAML file, and that will tell you how to wire up your images, what to run, and it was built entirely to do what I just showed you near the start. This is what a Docker Compose file looks like. As you can see, very simple indeed. There are only 3 images here. We supply the transfer one. This is our image. This is ultimately what we want to run. We say we build it using the Docker file in the current directory, and we want to link in Postgres and Elasticsearch. And at that point, we'll go, oh, I need to build Postgres and Elasticsearch. Where do I get those? Oh, I've specified them. We've supplied Docker files for Postgres and for Elasticsearch. Docker Compose will build those, run them. Only then will it run the transfer. It'll wire them all together for you, and then it will shut it all down and, with one command, destroy all the images for you. So you get this idempotency. Fire up, really easy. When it's done, tear it down, destroy it. You want to run it again? Do it with a clean, fresh build. So there's some code base out there, by the way, at the bottom. All these slides will be available later if you want to check out some of these links. But there is some code that I produced to show how to do this. You want to check this out. Now, one gotcha here is that right at the moment, the latest versions of Bamboo don't support Compose. They don't have Compose installed on them. Now, this isn't actually too much of a problem because Compose is really just a compiled Python script. So what you can do is just fetch it over the internet. So you're already running on, or could be running on AWS images. You've got the internet available to you. You add an extra stage in here that pulls down Docker Compose for you and installs it locally, and you can just run it locally from that point on. Again, this is a part of the power of Bamboo. Everything is really just scripting, and a lot of the higher level tasks are just pre-made scripts running on top. It's very, very powerful and quite low level when you want to do something that isn't necessarily straightforward using the existing tasks. So once you've downloaded this Docker Compose and installed it in your local build directory, you can just run it. I run it a couple of times. I do a kill and an RM. What that does is make sure any existing images are shut down. Not usually a problem for reasons I'll explain in a few seconds. And then we do a build and we do Docker Compose up, and that will run all of our tests for us, shut everything down, and we're done. The only other thing we do is, you may not be, if you're not familiar with this is quite a powerful idea. Because we want to be clean, we have a finally task. Now, finally tasks are a little bit like a finally clause in a Java try-catch exception catch. So the finally always runs, regardless of what happens within the exception block, and even if you get a failure within the exception catch, it will always run out that block of code. Finally, in Bamboo, does the same thing. It says this task will always run regardless of what errors you get during the run. So what we do inside there is just make sure we've shut everything down. Docker Compose is aware of the images that it has created, so it knows how to destroy them. So very easy to clean up after yourself. So this is really quite a powerful way to run it. You can run this locally, just install Docker and Docker Compose locally, and you can run your tests, and then you can just do exactly the same thing inside your continuous integration. I love to do that. I'm a little bit too proud. I don't like to see any errors appear in my builds, so I always make sure I run my builds locally first, and only then do I push it up. So I'm pretty sure when I do a push, that is going to pass the Bamboo builds. Because I have repeatability, because the stuff that's running locally is exactly the same as the stuff that's running on our continuous integration systems. However, there is one thing I have glossed over here that I will now drill into. How do you get results out? Docker's containers are self-contained. That means any files they produce, any data they produce in the process of the build will be hidden inside that container. It won't be in your Bamboo agent working directory. You want to get that information out. So how do you do this? This actually turned out to be quite easy. So Docker containers are self-contained file systems, but you can access those file systems even when the container is not running. So you need to do simply two things. We use Docker Compose to say, give me the ID of the container that I'm interested in this case, our transfer container. And then we just use Docker CP, copy, from CP is from the sort of the Unix Linux world, this means copy the file out. You can actually treat it almost like FTP, copy files in and out of containers, even when they're shut down. So we just copied out our test file. Our XML file was spat out by our tests. I'm using Closure, which can spit out JUnit tests, so I am going to use that. We have a whole bunch of parsers inside Docker itself. It understands a whole bunch of test framework output, but it also supports JUnit. This all happens magically for you if you're using Maven or any of the other normal build tools. It knows that it's going to check for test results. But in the case of Docker, it doesn't know that those test results are there. We just say we add an extra task into our job here to say, please parse the output of my tests. I've just dropped them in the directory. Please pick them up. You give it the file name, and it will, from that point on, will include them in your build results. Again, this is one of the powerful things about Bamboo and continuous integration in general, is it can track individual tests. So you can see which tests have been failing over time, which tests, you don't just get a pass if you fail or you've passed, and you go and work out, you'll actually say, no, this particular test is failing right now. So that's very useful. Now, I do want to talk about one last thing. How many people here are actually using Docker in a production environment? Okay, it's a few, more than I expected. That's cool. Good for you. We're actually doing it internally as well. We have our own Docker-based cloud system built on top of AWS. It's pretty cool, but that's beyond the scope of this talk. If you're building all of these Docker images, you might want to, and you have a production or a staging environment that runs Docker, you're probably going to want to push those images straight out onto that final staging or production environment for testing or for actual use. This is quite, this is one of the benefits of Docker. You can actually just build and test and just push this all out in one go, because all the dependencies are all self-contained. So how are you going to manage these, though? And this is not particularly specific to Docker, what I'm about to explain to you is one of the lesser known major benefits of Bamboo, certainly from my point of view. And I'm going to drill down into one part of this idealized pipeline here, deployment environments. Deployment environments are a way of managing your code at the end of the deployment pipeline. Bamboo understands that you may have different places that have different versions of the code running at any given point. In this particular case, you can see that we have a dev environment, a staging environment, and a production environment. And if you look closely, quite small lettering, sorry about that, you can see that there are different versions running in different places. You can also promote these. You can actually say, I want always to deploy, once that build passes, I want to deploy the resulting image up to my dev environment. And then I can promote it up to my staging environment, get QA involved perhaps, and then if they're happy with that, they give it a tick and it gets deployed up onto our production environment. This is how we do a lot of our stuff inside in the ordering, the purchasing systems. So how do you do this with Docker? Because you can do this with any system. I've written some fairly extensive blog posts and talks about this, about how you actually do this in practice, how we achieve this. But I want to talk specifically about how you do it with Docker right now. So there's a couple of little tricks again, just small things for reference. One of the ways you do this in the pipeline is you share artifacts. At each stage along the pipeline, you can say, okay, I've run a build, I've run a test. This particular output, be it a jar or war or whatever, it might be a Debian package or whatever. In our case, it's a Docker image. I want this to be part of the ongoing pipeline. So we share it. We specify that we have a transfer.image, a Docker compact up image, and we can then pass that along down the pipeline, particularly down to the deployment environments. And in the deployment environments can use that and push it out to wherever it needs to go. Deployment environments are actually really very simple. They are very similar to normal build jobs. They are a bunch of tasks that you configure at the end. So in this case, we've created a testing environment, and we set a bunch of tasks. The task in this particular case, the first thing we do is we download the artifact that was shared in the earlier stage of the pipeline. We have a script that will load the transfer image into our local Docker repository, and at which point we can start manipulating it. And the next thing we do is we run the Docker image. Now, the way Docker works is it's network aware. So we can either run that locally, if our agent is running inside our actual environment itself. You run the Docker agent inside the machine that it's going to ultimately be deployed to, you can just run it locally. Or you can just set a bunch of environment variables and get the Docker command line to push the image up to any remote server that is listening with your, on the Docker port. So this is the basic idea. So jump back to this pipeline again. You can basically create images, you can build them up into little networks, and then you can test them, and then you can ultimately deploy them out onto your production environments if you are running Docker out there. But even if you're not running Docker out there, it is useful right now. If you have a complex integration testing system, if you want to test against real databases, and ultimately if you're going to be confident in your testing, then you really have to do this. We used to have a really complex Maven setup that will fire up HornetQ, will fire up Postgres, because we're running a transactional system against a real database. If we want to be sure that our transactions are working correctly, we have to run them against real databases, one that mirrors production. However, I really wish when I produced those Maven build systems that I'd had Docker at the time and Docker Compose, because that would have made my life a lot easier. I wouldn't have to muck around trying to manipulate, start and stop a Postgres instance from within a Maven file. Trust me, that was not a barrel of laughs. So this is a very, very powerful way of testing in as close to the real world as you possibly can, in a repeatable way on your desktop and in your continuous integration environment. So just to finalize, slides will be up, will be available quite soon, I believe. So here are some links that might be of use to you, but the slides will be up on our site pretty soon. If you want to take a photograph now, it's probably a good time, but otherwise, I say they will be up there. Or just straight Googling will give you a lot of this information as well. But that is pretty much it. It's a very powerful way of solving a real annoying problem, and it makes life a lot easier. Hopefully this is of use to you. I don't really have time for questions, but if you want to ask any questions inside the Atlassian Summit app, I will endeavor to answer them today, or I'll be down at the hub down there if you want to come and talk to me in person. So hopefully this is of use to you. Thank you very much.
Give it up for Steve. And yes, you are going to put you to work later because you have a lot of questions in the app.
Okay, cool. Thank you.
So thanks for asking the questions. Everybody, like he said, go ahead and put the questions in the app. And also don't forget to take the survey for Steve. He always loves to hear how he did and what you thought about the content. Up next, we actually have Game of Codes, the Battle for CI with Esther. And it's good. I've seen it before. She's on the Bamboo team, and so that will be starting in exactly 15 minutes at 2:45. So you guys have a little break, but I'll see you back in here in 15.